In this video, try to explain how to formulate the mini case 5 fertilization problem. We do not repeat the text in the problem, but I do strongly suggest you to go through the description of the problem. So we start with the define decision variables. So first step, we define decision variables. So we let the quantity of each, let xg be the purchase quantity of each type fertilizer. G equals to 1, 2, 3. We can actually put this decision variable in your table 6 to help you to understand. So that's x1, x2, x3 here. And the next step, we try to formulate the objective function. So we know, or we can see the cost for each type of your fertilizer is given. Then this problem is to try to minimize the cost for the combination of the fertilizer. Then we can just write 10 times x1 plus 8 times x2 plus 7 plus x3. So we try to minimize this total cost. And the third step is the constraints. Formulate the constraints. In this problem, we know each type of fertilizer includes 3 types of. So if we use G, we do not define. Not necessary to define that. Just wipe it. So we know each fertilizer actually includes 3 different types of content: nitrogen, phosphorus, or potassium. Now the question is, for each type of mineral, there's a minimum requirement or least requirement in kilos. So these are the 3 main constraints we first try to formulate. So first, based on table 6, we actually can see for each type of fertilizer, and then you can just focus on the first row, and then we have the each content based on x1, and then each content based on x2 and x3. And then we know your constraint actually is based on the mineral content. So we try to calculate the total quantity from 3 fertilizers for each content. So the constraint 1, we try to see, is for nitrogen. And then we try to use 3 types of fertilizers quantity times the content. So 25 x1 plus 10 x2 plus 5 x3 is the total content for nitrogen. And we know the constraint should be greater than or equals to 10 kilos. So that's how we formulate the first constraint. And then we have C2 for phosphorus. Then you have 10x1 plus 5x2 plus 10x3 greater than or equals to 7 kilos. Then we have constraint 3 for potassium. Then we have 5x1 plus 10x2 plus 5x3 greater than or equals to 5. So that's the first 3 constraints based on table 5 for the contents. And then we also have a constraint is the total quantity, that total quantity for purchasing actually should be only 1 ton. So the total fertilizer allowed to use maximum is 1 ton. So we have the fourth constraint, actually x1 plus x2 plus x3 should be equals to 1 ton. And of course, do not forget your non-negativity constants. So all the xg should be greater than or equals to 0. So this is the model formulation for the mini case 5. From this case, you should also try to understand when you have a mixing problem, you could just put all the parameters into a table that may help you to actually understand and formulate the problem.